Okay, today we're going to be talking about rates of change, and we're going to be talking specifically about two types of rates of change: average rate of change and instantaneous rate of change. So the best way I could actually explain this would be, let's say you're driving from Dallas to, let's say, Houston, and I don't know, let's just say it is 200 miles, and it took you 4 hours. That means you averaged 50 miles per hour. It doesn't mean that you went 50 miles per hour the entire time. Maybe you stopped to get lunch, maybe you stopped to go to the bathroom, maybe there were some traffic lights, but you averaged this speed. So I took your total change, so let's write it this way. Total change in your distance divided by the total change in time, and that's how we get average speed. Now, let's say I wanted to know how fast were you going at exactly 3:24 p.m. That is called instantaneous rate of change. In other words, how fast were you going at a specific instant? This is how fast were you going as an average speed throughout your entire trip. So those are the two types of rates of change that we're going to look at in this particular video. So the first problem we are faced with is to find the average rate of change of f of x equals x cubed minus x over the interval 1 to 3. So essentially, we can simplify this, and what we're looking for is the total change in the y-coordinate divided by the total change in x. We've seen this before. This is your basic slope. So when you see average rate of change, from now on, when you see that, I want you to think of the word slope. Just y2 minus y1 over x2 minus x1. That's just your average slope. So let's go ahead and find that. When we plug in our x2 of 3, we get 3 cubed minus 3, so that's 27 minus 3, 24. Divided by the total change in x, which is 3 minus 1, that's 2. So our average rate of change is going to be 12 in this interval. Okay, next we're going to talk about two very special types of lines that you have to be comfortable with dealing with when you're dealing with the curves. So let's say we have this blue curve, looks like some sort of parabola maybe. And let's say we have a point that's here and another point that's here. The line that goes through both of those points is called the secant line. The line that touches one point on the curve, like this burgundy line, is called the tangent line. Starts with a T, touches, tangent. So this is the tangent line, and this black line is the secant line. It goes through the 2 points on a curve. So let's see if we can find the slope of this secant line. Let's say this is some random x coordinate A, and let's say there is a distance from this first x coordinate to this next x coordinate of h. That means that this x coordinate is going to be A plus this distance of h. Well, what about the y coordinate? We're going to call that f of a, meaning the result that you get when you plug a into the function. So this is the y coordinate associated with a, and then f of a plus h is consequently the y coordinate associated when you plug in this x coordinate of a plus h. Let's see if we can find the slope between these 2 points. So it's going to be y2, which is f of a plus h, minus y1 f of a, over the difference between these two, which is just h. Now that is the formula for the slope between these points. But now watch what happens. Let's just say we wanted to find the slope of this tangent line right here. Well, what would happen if we allowed the space between these two x's to get as close to 0 as possible? Let's say we moved it here, then we moved it here, then we moved it here, then here, then here. Almost to where the 2 points are on top of each other, the question I want to ask to you is, if we found the slope between 2 points that are infinitely close to each other, wouldn't that be very, very close to the slope of this tangent line right here, especially if I put it like right on top of each other? That's the idea behind a derivative, or the slope at a specific point on the graph, not between two points on a graph, but the slope at a specific point. So what we need to do is we need to write the limit as h approaches 0, meaning h, the distance between these two x coordinates, is approaching 0, of f of a plus h minus f of a over h. And you'll normally see it as f of x plus h minus f of x over h, because this is normally referred to as x. So this is how you would find the slope of the tangent line to the curve. And this is how you would find the slope between 2 points that are on a curve. All right, we are in the process of learning about the derivative, but we're not yet calling it that. And so example 3 wants us to find the slope of the parabola, f of x equals x squared at the point 2, 4. And then it says, this is called the instantaneous rate of change. Write an equation for the tangent to the parabola at that point. So let's just give you a visual perspective of what we are trying to accomplish here. Let's say this is our xy axis, and let's just say this curve is our parabola, y equals x squared. All right, and let's say in red, this is the point 2, 4 right there. So what we are trying to do is we are trying to write the equation of this tangent line that touches the curve at 2, 4. So that requires us to remember something very important. We need to, and this is very important for you to keep in mind throughout the entire year, because you're going to be writing tangent lines all year long. You need to use point slope formula in order to write the equation of a tangent line. Very important formula. Make sure you have this memorized, because you're going to be doing it all year long. So let's see. All we need in order to use point slope is 1 point, which we have, 2, 4, and the slope of that line, which we will get by using this equation right here. This is the equation for your slope. So let's go ahead and do that. Let's go ahead and do the limit as h approaches 0. F of x plus h means take x plus h and plug it into the formula. So x plus h squared minus f of x. F of x is just x squared over h. Now, we've already done these limit problems before, so you should have a good idea how to do this. You need to FOIL this. Please don't make the mistake of squaring x and squaring h. You need to actually FOIL this out, so x plus h times itself. When you do that, you'll get x squared plus 2xh plus h squared minus this x squared right there over h. And of course, just like all great limit problems, these are going to cancel, leaving you with something on the top that only has h's in it. So this is your key right here. You need to make sure that all your terms that are left have h's in it, because you're going to do something with that. You're going to factor that h out, my friends. And you're going to factor that h out, and that's going to leave you with 2x plus h, because you can only factor one of those out, over h. And then we have this situation that we love. The h's cancel, and then we need to remember to take the limit as h approaches 0. Don't forget this last step. It's very important. And so we're going to plug 0 into our limit, and we're going to get 2x. All right? So we're going to get 2x. Now we're going to plug in the x coordinate of the point that we are trying to write the tangent line of. That's 2. That's going to give us a slope of 4. Now we're ready to write our tangent line. So it's going to be y minus 4, the y coordinate of the point, is equal to m, which is 4, times x minus the x coordinate of the point, 2. And that is essentially how you would write the equation for the tangent line. All right, example 4 says, let f of x equal 1 over x. Find the slope of the curve at x equals a. All right, let's go ahead and do that. So we're looking for, let's see if we can make sure we understand this. We're looking for the slope of the curve at a specific point, not between 2 points. So that means we need to use this formula for a derivative. And once again, a derivative is the slope of the curve at a specific point. So let's go ahead and do that. F of x plus h is going to give us 1 over x plus h minus f of x, which is 1 over x, all of that over h. Don't forget, limit as h approaches 0. So we need to get a common denominator between these two fractions. So maybe we'll multiply by x plus h here. And here we'll multiply top and bottom by x. And that's going to give us a numerator of x minus parentheses x plus h over the common denominator of x plus h. But please don't forget, this is still all divided by h. So let's go ahead and distribute this negative, and that's another thing you have to be very careful to do. Distribute the negative inside here, and that's going to give you x minus x. The x's are going to cancel, but you still have a minus h. So negative h over the common denominator that we found, x plus h. Now, I'm going to do another step here. Instead of dividing by h, I'm going to multiply by 1 over h because that's how you divide fractions. And then the h's will cancel. And there you have your, you have negative 1 over x times x plus h. And then don't forget, you have to take the limit as h approaches 0. Plug that in there, and you have your slope of this curve, negative 1 over x squared, and this is the slope of this curve at any random value of x. So once again, if I looked at this curve, we know that the curve would look something like this. This is your reciprocal function. So what I've done is I've found the slope at any value of x. Notice it's going to always be negative. Well, that's because if you draw any tangent line to this curve, maybe that line, or that line, or that line, or that line, they're all going to be negative slopes no matter where you draw your tangent line. Okay? So it says plug in a, and we did that, so the slope is going to be negative 1 over a squared. And that's as far as you can go with this problem. Now it says, where does the slope equal negative 1/4? So if this is our slope, all we need to do is plug in negative 1/4 in for our slope, and we need to figure out what x value gives us that, or x values. So we can see that it's going to be 2 or negative 2, because either one you square is going to give you 4, and that makes these two fractions equal to each other. So x equals 2 and x equals negative 2. All right, that makes sense, because if you look at x equals 2, there's a tangent line right there, and there's a matching tangent line over here on this curve that has the same slope of negative 1/4. Okay, example 5, we want to do a similar type of exercise that we did before with the tangent line, except this time we want to write the equation for a normal line. And just to help you visualize what a normal line looks like, let's say we have, once again, our x and y axis, and let's say we have some curve. We'll just say we'll just use our good old parabola again. And let's say we have some special point on that parabola. Let's say it's 2, 4 or whatever. And let's say we have our tangent line, which looks like this. Our normal line is a line that is perpendicular to the tangent line that goes through the same point. So the blue line is our tangent line, and the burgundy line, or red line, is the normal line. What do we know about lines that are perpendicular? They have opposite reciprocal slope. Opposite meaning different sign, reciprocal meaning flip the numerator and denominator. So we need to first find the slope of the tangent line, just as we've been doing in the last two examples, and then flip that and change the sign, and we've got the slope of the normal line. So let's see if we can go ahead and do that. First, we need to find the actually find the slope of the tangent line. So we're going to use that same formula, and we're going to put x, actually let's use white, x plus h. We need to plug that into our formula. All right, so that's going to be our f of x plus h minus f of x, which is, and notice I'm using brackets to make sure that I'm grouping things properly. All of that is over h, and don't forget, limit as h approaches 0. Okay, so now we just need to FOIL this out. We did that earlier, so I'm going to go ahead and write that down. 4 minus x squared plus 2xh plus h squared. And I'm going to go ahead and distribute this minus into here. So it's going to be negative 4 plus x squared. And now I'm going to distribute this negative into all of these. So I'm going to end up with 4 minus x squared. You've got to be very careful with your algebra here. Very careful, because it's easy to make mistakes. Okay, but one way that you can know that you did it correctly is if all terms that do not have an h cancel out. X's cancel, 4's cancel, and what's left? Terms that have h's. All right, so we're going to do the same thing we did before. You have negative 2xh minus h squared. Don't forget, this is still all divided by this h here that I've left out. And you have to continue writing the limit as h approaches 0. We're going to factor out the h on the top. It's going to leave you with negative 2x minus h over h. And we're going to cancel the h out. And then we're going to plug in our, we're going to plug in our 0 for h, and we get our slope. So we'll say our slope is negative 2x. All right, but they give us an x value of 1, so we know that our slope is negative 2. So I'm going to erase a little bit here so we have some space. So we know that our slope is negative 2. So let's go ahead and kind of erase a little bit. So we can write our equation for our normal line. Now, if our slope of our tangent line is negative 2, that means the slope of our normal line, which is what we're trying to write, is positive 1/2. So we are going to, well, we have to plug in x equals 1 into the original function to get the y. So don't forget, guys, f of x is what you use to get the y value, and this new formula is what you use to get your slope. So let's plug in 1. We get 4 minus 1, which is 3. So the point that we are trying to write the normal line that goes through is 1, 3. So we're going to write y minus 3 is equal to the slope 1/2 x minus 1. And the good thing in calculus is that most of the time you can leave your answer in point slope form. For the sake of time on this video, we are not going to do example 6 on this video, but please copy it down and try it on your own. And if you have any questions, you can check my website and you can look at the PDF, which has all the solutions written out for you.